New section is 3.2, solving inequalities by adding or subtracting. This section is going to have a lot in common with what we did in the last chapter, where we were solving equations, things with an equal sign by adding or subtracting. So this Roman numeral 1, solving, you could write the whole thing if you wanted to. I would just write what's underlined. And I'd put like Roman numeral 1, solving, put a star, copy the inequality like an equal sign. And I'm going to show you what I mean by that in just a minute. So I guess give you a second to copy or keep going? Okay. But I would just do the underline, copy the inequality like an equals. I suppose after a couple examples, you probably could even just kind of skip that. It'll make sense. So I'm going to do the example x minus 5. And instead of saying equals 8, the new thing now is you'll get like a less than or greater than symbol. So x minus 5 is less than 8. And really, you can treat that just like the inequality sign as an equal sign. If it was x minus 5 equals 8, what would you do to both sides to get x by itself?
Plus 5.
Yep, you look at what was done to x. 5 was taken away from x. You do the inverse of subtracting 5. You add 5. And you have to do it to both sides, so you're not changing the value of one side and not the other. When I do that, my minus 5 and plus 5 cancel out, and I'm just left with x on that left-hand side. On the right-hand side, I get a 13. And just like before, we would just copy down the equal sign. Now you just copy the less than. Make sense?
Yeah.
If we would take what we did yesterday in class and said, all right, now I want to say, here's the solution to it. X is less than 13. Do I put an open circle or a closed circle?
Open.
Open, because x doesn't equal 13. It has to be smaller than that. And now I shade to the left side. So I'm going to shade to the left. Make sure you make the arrow at the end larger also. But that would be kind of the graph solution to first example. We okay on those? Yeah. So second example, then we'll move on. So I have x plus 7 is greater than or equal to 13. So what do we do to both sides here? Yep, see a minus 7, just like we would do if it was an equal sign in that. So I have x now by itself. Copy that same sign, so it's greater than or equal to 6. Still good? Makes sense? So really it's identical to what we were doing yesterday, or what we were doing in earlier chapters, but you just copy down this sign. And that'll change a little bit when you do multiplication and division. If I wanted to graph it, open circle, closed circle? Close, because 6 is greater than or equal to 6. 6 has to be part of the solution. And numbers that are greater, we shade to the right. Okay. Then the next page is limited domains. So Roman numeral 2, limited domains. And I'm going to write this. I'm going to put a little star for dramatic emphasis and say, be careful in story problems that the answer makes sense. So be careful with story problems. That the answer makes sense. Like that example I was doing before, both those examples, it was just x minus something is less than 8. X plus 7 is greater than or equal to 13. We have no idea what x is. Ones like that, it doesn't matter. You solve them just like we did. But now, as soon as we get a story problem in there, the story problem could change it. Because you could come up with your answer, x is greater than or equal to 6, but maybe 6.5 doesn't work. It doesn't fit for the story problem. Okay, so here's my example. I wouldn't write the whole thing. I would just write puppies, and then you could do like the little p in parentheses if you wanted to. But we just want to say that, so you could write out the whole thing. You could just say, okay, p is going to stand for a certain number of puppies. Mr. Falk bought some puppies to give away in class. Aww. That'd make me maybe loved by some students and hated by some parents. But okay, if 3 ran away and he doesn't have enough for everyone, how many could he have brought? So I wouldn't write this whole thing. You're just going to know that P stands for puppies. How could we take and change this into an inequality of some sort? So I bring in some number of puppies, so P. 3 ran away, minus 3. And I don't have enough for everyone. Well, there should be 16 of you guys. So less than, is it less than or equal to or less than? If I don't have enough for everybody, less than or equal to, would I have enough for everyone?
No.
Yep, because I'd have enough for like one per person. But we don't have enough for everybody, so it's going to be p minus 3 is less than 16. Good? So you don't have to write the whole story problem as long as you know p stands for puppies and we have this p minus 3 is less than 16. All right, so now to solve this thing here, we do what to both sides? So plus 3 and plus 3. I'm showing my work in a way that my teacher will give me full credit. Woohoo! So p is less than 19. So I started out with less than 19 puppies. Agreed? So before we were saying, all right, if I take my little number line and I put my 19 on there, open circle, close circle, open. I wouldn't do this necessarily yet, but open circle there. And if p is less than 19, I'd shade to the left. So I wouldn't put this down because this isn't the right answer, maybe. Do you agree this includes 18.5? Could I have brought 18.5 puppies?
Yes.
Yes, I could have, but that's like sick and wrong, right? Or 18.1 puppies. You know, it's like I bring in 18 puppies and a severed puppy leg. You know, it's just, it's gross. Should have done that without the... Oh, by the way, do you know how you make a dog go meow? Freeze it and run it through the bandsaw. Meow.
Oh my gosh.
Okay. Going to be some editing on this video, but okay. Where do you find a dog with no arms and no legs? Right where you left them. Okay.
No, you should keep them. You put the videos on YouTube, right?
Maybe. Okay.
I was watching one last night.
Okay, we should. I'm a totally depraved individual. I have a book of jokes, and those are two of the ones I remember. So. There's more. Okay, let's move on, shall we? So this doesn't work as a solution. I'm going to just give myself a little bit more space on the page. But we can't say this is a solution because it's going to include like partial numbers of puppies, and that just doesn't fit. It's not a limited domain. But I could have brought in 17 puppies, right?
Yeah.
Or 16, or 15, or 14. Could I have brought in 18 puppies?
No.
Yes. Could I have brought in 19 puppies?
No.
No, because it's p has to be less than 19. So how I should be graphing this would be something like, I do like my monstrous number line here, and okay, 18 you said was the highest number of puppies I could have brought in, so I put a dot on 18. Then my next line would be 17. Then I'd have 16. And you might want to go and like put in some other numbers. So now I know that each one is 1. And 15, should have picked a smaller class size, 14, 13, 12, 11, 10. Is there going to be a lower limit? I'm hearing 0. I couldn't have brought in a -1 puppies, right?
Yeah, you could.
So 9, 8. Now, if p is the number of puppies I brought in, technically I pulled a little trick on you. P can't be 0, you're right, but could p be 1?
Yeah.
Let me quick finish this. Because if p is the number of puppies I brought in, 3 ran away, right? So the least I could have brought in would be 3, because 3 ran away. So I'd have 10, 9, 8, 7, 6, 5, 4, and 3. So.
Man, this seems tedious.
Yeah, I should have picked a smaller class
Are they
size.
all going to be this big?
But it doesn't make sense to have a negative number of puppies. 3 of them ran away, so I know I had to have more than 3. The other way that you could write this would be this here. So you could say if you had to graph the answer, the solution would look something like this here. You know, this number line full of dots, so we don't have partial puppies. If you're writing your answer as this thing here, the p is less than 19, you'd have to say something like where, we want to say no decimals. So you could say p is what kind of number doesn't have decimals? You could say whole, you could say natural, you could say an integer is a whole number. So pick any one of those 3. Whole, integer, natural. But then we'll say greater than. You could say greater than 2, or you could say greater than or equal to 3. 3. Oops. Greater than or equal to 3. So there's options for how you could write it, which makes it a little bit more of a pain for checking your answers. But does it make sense?